Welcome to the video notes for lesson 10-2, dilation. This begins on page 8 in your notes packet. Let's go ahead and take a quick look at the learning targets. There's a couple of them. I can determine the scale factor of a dilation. I can use a scale factor to determine the points of a dilation. And the last one, I can graph a figure and its image after a dilation. So a lot going on in this lesson, so make sure you pay attention. The key concepts: a dilation is a transformation that moves each point along the ray, there's a vocabulary word that we need to talk about, through the point starting from a fixed center, and multiplies distances from the center by a common scale factor. And you've heard that word or phrase used a lot, scale factor. Typically, if you look at this picture here, all of this is expanding out of the origin. So this year, in this topic, we're focusing on the dilation, that is multiplying is from the center from the origin. The scale factor is the ratio of a length in the image to the corresponding length in the original figure. So if the length in the image is 10 feet and the length in the original figure is 5 feet, then the scale factor is 2. To go from 5 to 10, you multiply by 2. And we've talked about that. Okay, so there are two types of dilations that we talk about. There's enlargements and reductions. Actually, let me clear the screen and move this up so we can see it better. So an enlargement is a dilation with a scale factor greater than 1. After an enlargement, the image is bigger than the original figure. So the minute that we're talking about a number greater than 1 as the scale factor, then we're making a bigger image. A reduction is a dilation with the scale factor less than 1. Now, to be more specific, it's actually between 0 and 1. If it's a negative number, it'll actually send it the other way through the origin. And we're not really going to focus on any negative numbers. So a reduction is smaller than the original figure. The numbers that we will typically see are fractions or decimals because they're between 0 and 1. Okay, so over on the next page, page 9, we will see some examples. So for the given dilation, find the scale factor, then decide whether the dilation is an enlargement or a reduction. So I'm actually going to do that first. So when I look at the picture, I see in this first one to the left, I see PQRS is the smaller figure, the original, and then P prime, Q prime, R prime, and S prime is the larger. So the original is the smaller, the image is larger. So this one is an enlargement. And then in the picture to the right, so you'll notice that LMNP is the original figure, L prime, M prime, N prime, and P prime is the image. So I'll put the O out here for the original, the I in here for the image. So this one is a reduction. We're making the image smaller. Now you'll also notice that in my copy of this, I have different colors so I can tell them apart. Yours are all black and white, so it might be a little more of a challenge. Okay, now let's talk about finding the scale factor. So this line, PS, if you count the spaces, it's 1, 2, 3. And the line P prime S prime, the corresponding segment, I should say, is 6. So then that means the scale factor is, to go from 3 to 6, is 2. So this is one way of finding it, is if you've got a side that's measurable, measure it, and then, I forgot to count the spaces up here in the picture, and then you can find what you, now remember, we're always talking about multiplying when we do scale factor. So to go from 3 to 6, you're not adding 3, you're multiplying by 2. The other strategy for doing this is, look at the point P, and the coordinates for P are 1, 2. What do I do to that to get P prime, which is 2, 4? Now, look what happens with the x values. Let me switch the color up here. Look at what happens with the y values. Again, we're talking about multiplying. 1 times what gives me 2? 2 times what gives me 4? And the answer is times 2. So, and then for a rule, we have x comma y, arrow, 2x, comma, 2y. Alright, and we've already done a little of this in class, so this should all start to make some sense to you. Now for the reduction. Remember, with a reduction, we're looking for a number between 0 and 1. So we're looking for a fraction or a decimal, okay? Alright, so the first strategy is to, again, use a side. So side LM. So if I count these spaces here, 1, 2, 3, 4, 5, 6, 7, 8. This is 8. L prime, M prime. That side is 1, 2, 3, 4. So how do I go from 8 to 4? Now some of you might be saying, oh, well, you divide by 2. We cannot think of it in terms of division. Or, well, if you do, you've got to remember that dividing by a number is the same as multiplying by the reciprocal. So if I divide by 2, multiplying then is by the reciprocal, or 1/2. So the scale factor is 1/2. Again, the other strategy, using the points. So if I use point L, find the coordinates of L, and that is at -4, 4. What do we do to get to L prime? And L prime is at -2, 2. Go from the x coordinate to the x, and in this case it won't really matter too much, the y coordinate to the y. How do I get from -4 to -2? How do I get from 4 to 2? We multiply. Well, some of you might say, oh, you divide by 2. Now we got to think of it in terms of multiplication. You're multiplying by 1/2. A rule for this, x comma y, arrow, 1/2 x, 1/2 y. Pretty easy. Oops. 1/2 x, 1/2 y. Alright, so this is one example of what we're talking about with enlargement and reduction. Okay, let's take a look at the problem at the bottom of the page. To find the image of a figure in the coordinate plane after a dilation with a center 0, 0, so we're doing this through 0, 0. That usually you'll see, even though it doesn't change what we do. You can multiply the x and y coordinates by the scale factor. So draw the image of triangle ABC after a dilation with a center 0, 0 and a scale factor of 2/3. Alright, so what are we doing here? First thing, let's start with all our original points. So we have A, which is at 3, 6. Leave a little bit of space, B, which is at 6, -3, and C, which is at negative 3, 3. Now, watch what happens. We know our scale factor is 2/3. Because it's a number between 0 and 1, it's going to be a reduction. The rule is going to be, we go from x comma y to 2/3 x, 2/3 y. So, watch what happens. A prime, then, is 2/3 times 3, and yes, you may use a calculator, 2/3 times 6. Calculator might slow you down, though, because watch this. So, 2/3 times 3. You can either do 2 times 3, which is 6, divided by 3, which gives you 2, or some of you might recognize that, oh, hey, the 3's cancel out. Well, here, if I cancel out the 6 and the 3, I have 2 left over. 2 times 2 is 4. That was also pretty easy. So, my point is, A prime is at 2, 4. Go over 2. Whoops, over 2. Up 4, put a dot, and that point is right there. That's A prime. Remember, this image should look smaller. Okay, we are going to, actually, you know what, this video is getting a little long. I want you to try B prime and C prime on your own. Let's take a quick look over onto page 10. So your job is to finish the one we just started. Okay, on page 10, the vertices of triangle ABC are A is at 1, 2, B, negative 2, 1, C, negative 1, negative 1. Use arrow notation to find the coordinates of triangle A prime, B prime, C prime, the image of triangle ABC, after a dilation with center 0, 0, and a scale factor of 3. Then graph triangle ABC and triangle A prime, B prime, C prime. You are definitely going to do this last step all by yourself, because that's not that hard. So first thing, I'm going to write 1, 2, negative 2, 1, and negative 1, negative 1. Now, they give us the rule right up here in the top of the table. So we're going to multiply 1, 2 by 3, and you get 3, 6. And for this one, you get negative 6, 3. And then for the last one, you get to do that on your own, right, in arrow notation. So this is going to be x comma y. This is the rule, arrow, 3x, oops, comma, 3y. So A is at 1, comma 2. Arrow, A prime, 3, comma 6. Now, you need to write the rest of the table down here in arrow notation, starting with B and B prime, and then you got to find C prime. Then graph all of that, and you will be done. And this video is done. If you had any trouble with any of this, go back and rewatch it, or come and see me for help. Good luck, and we will see you in math.